Okay, uh, welcome everybody back from lunch. Let's start our first afternoon session today. And I want to welcome our first speaker, Valera Veryazov. Yeah.
Thank you very much, Chairman. I would like to start from thanking the organizers for a great opportunity to be here. And since I made quite a long journey from Sweden, I decided to have several topics in my talk. I will not talk actually about my recent research and science, because I'm doing some basis set development and development of model potentials. So if you would like to talk with me about why you shouldn't use double zeta basis sets or how to use multi-configurational theory with solids, you are welcome to speak with me a little bit later. But today I will be talking about three subjects. And I hope that the chairman will stop me in the right moment. I will first of all talk about code development, and I will use as an example Molkas and Open Molkas. So you probably will learn a little bit of development of the story. And I will have some couple of programming exercises where indeed naive, because I was doing this work just on a way here. So it was just a couple of hours work, but I was trying to find out the answer to the questions how we can improve our code development in different ways. So let me start from some rational observation about the development of software in natural science. It's quite special things actually, because you know that there are quite many programmers on this planet. But most of them were busy with other things. We are making games, we are making some useful tools, which we are all using every time. But the market for quantum chemistry is quite special. And you clearly see this, that it's very difficult to find the good programmers. And if you find them, sooner or later, well, they disappear because they find another job. And then you have a lot of codes which is not supported. It's a typical problem for all of us. And it's a common dilemma for a PhD student. I'm writing a code for what? To write a paper or think that how my code will be used in different places? And of course, as a result of this, it's quite common situation that documentation is lacking. There is no any clear documented API, so it's very difficult to connect this code with others, and very minimal support. So it's a typical thing. And when it comes to money, well, you will find out that it's much cheaper to buy any code, even expensive one, rather than write your own. It's true. And if you're asking some money from grant givers, I have seen this answer many times. Are you saving the planet? Are you trying to develop a new drug or new solar cell? No, we are developing tools. And it's really not attractive from all sides. And of course, ideas and algorithms, especially when talking about open source software, they have lags. So it's not very easy to develop software. I will be talking about one particular thing, Molkas, and I think that there is no need to introduce this package here. It was done many times and on some previous occasions. But briefly speaking about this, it can do many things. But our strength, our strongest part is multi-configurational theory, because we can do very nice CASSF, RASSF, GASSF, DMRG, stochastic CI, and on top of many of these things, you can do perturbation theory, which is very nice. And we are started in beginning of 90s. Then some group in Lund realized that it's a good idea to collect different small pieces of the codes which are running in different platforms. And sometimes I heard the stories that some integrals was transferred from Stockholm to Lund on a tape. magnetic tape. So it was really tempting to have one place and one package. And so I think that the first release of Molkas was 1994. After that, we were doing a lot of nice things. We were trying to make this attractive for development, for making organized in a nice way. But things happen, and in some moment, the code started to dissolve, possibly mostly because all main developers, they started to be old or passed away. In 2017, a great thing happened. We had the LGPL release, OpenMolkas, and since then, OpenMolkas and Molkas, they coexist. And I will show you what was the change and how they doing this coexisting. So this is a picture from 2005. Perocke, Bjorn, Per-Olof, Roland, and I'm making this picture so you can't see me here. This is an environment when we were how we were developing Molkas. Of course, not all the time, but sometimes we had an opportunity to rent some nice place like this one and sit down and work on some specific problem. And you can see that it's indeed solving some problems. Now we have a complete change. A lot of people, a lot of new people, some of them I even don't know by names or by faces, but they're all happy. This is what we have now. We have a big community, open Molkas community, and of course, it brings some good and bad things. So how they coexist? The idea of Molkas always was that this is a user-oriented project. We have some limited support. We have some helpline. You have problem with installation. And so basically you take this code, well, you have to pay a little bit of fee and then it runs. But I would like to stress this, Molkas never was and never will be a commercial code. It's a university project. And all the small revenue which we are receiving sometime, it goes to this cleaning up and support. So it's not a commercial thing. And it gives some ability to actually, if you need to do some calculations, especially in multi-configurational theory, you buy this package and you run it. Of course, there is another alternative. You can use OpenMolkas. You just download this from GitHub and it works. And it also gives a freedom for development. And this is a great thing, of course. And we're still having some releases of Molkas, and next one will come in soon. And we are trying to, of course, it's based on open Molkas development, but we are trying to make, to clean up all corners to make it really easy to use. So what went well with this development of open Molkas? I think that the greatest achievement is that we now connected to very many other codes. So very many packages, like in DMRG domain, in stochastic side, molecular dynamics, DFT library, which we can now use, several MRCI codes, they are connected to open Molkas. And this is a really good thing. We have a little bit, well, increase of users. We have some discussions in the user forum. We have a big amount of new changes. Not of them where actually have sense, but at least it's a big amount. What didn't went well, I would say, documentation. Because user documentation now is a little bit behind the development. Programmer's guide, which we have, it simply disappeared. And it was difficult to support this. And also, obviously, quite many platforms which Molkas earlier supported, they simply stopped being supported. Because before, well, it's still, Molkas is trying to claim that we are running on all platforms with all possible compilers. Nice features which we had in Molcus were simply probably waiting for the time when they will appear in open Molcus. Like we don't have any organization which makes this decision. So it's just some meetings which we have. We don't have a planned development. We don't have training for users because the last training workshop was done in the time when Molcus was the only program. And there is basically no training for developers. You're on your own. You can download this, learn it, and use it. One important thing, at least for me, as a criteria of successful of a project, is how many times it's cited. In the 90s, it was only citations for the manual. It was a small amount. And it first kick up was in the moment when we find out a funny conference which actually had proceedings published in the journal. So we had our first publication for Molcus in 2003. And then the curve started to grow. It continued to grow when we have some papers about Molcus 7, Molcus 8. And at that time, we were able to sponsor some conferences. It was, of course, a small sponsorship, but we sponsored even Valera conferences. And we had a lot of users workshops. So you can imagine how this curve will go after release of Open Molcus. Oh, sorry, spelling mistake. It didn't go up. Of course, there are some possible explanation for that. That it was a sharp decrease of resources, so we are not able to make some promotion for both Molcus and Open Molcus. It can be COVID, it can be a market situation. So this is a little bit alarming thing. So it means that the number of users increased dramatically, but the number of users who using this seriously, publishing papers and citing the codes is not increased. So conclusion for this part, I think that maintenance and development of software in science is a specific thing. We need to pay a little bit more attention to all this stuff. And just changing the model from closed or one group program to open source, it doesn't solve all problems. You need to work hard in order to solve this, and my plans is to push a little bit Open Molcus community in this direction, so we can actually regain some institutes, some ideas which were working in Molcus. And of course, some development like GUI parallelization, development of tools, it's a little bit slowed down now, because indeed, if you have this kind of software, it's only runs by personal initiative, so to speak. Okay, so now I'm jumping to the second part of my talk. And I will speak about how to test your software. Because when you have your code, it's very important that the code produce the right numbers. And first of all, it's important to understand what is the reason for the code not producing the right numbers. The biggest problem is, of course, that you make an update which contains a bug or some side effect, and then some numbers are not produced well. But there are other possibilities that some compilers can over-optimize your code, or some new versions where completely differently interpret your code. And there is a simple way how to check this. You can do the testing. So you have some reference numbers made on some not optimized version on some very specific computer and so on. And then you can compare these numbers. Sometimes, if you're lucky, you can do some cross-program check. For instance, to check energies computed by one program and another program. And I would like to note here that there are some problems with testing of scientific codes, because sometimes it's iterative algorithms, so error can be accumulated. Sometimes you have some funny rounding errors and parallel calculations, so your code is computing numbers in a different order. Back to year 2000, we started to think about some testing of Molkas code. And actually it was Roland Lind who started to write some testing system. And when I saw this, I asked him to please give me some time because I have some better ideas. And he gave me 2 days. And after 2 days, I end up with a solution which works for last 2 decades. This solution is based on several simple things. We would like to test only meaningful data, energies, dipole moments, so no testing for intermediates. And we have some call, it's a Fortran call, which has a label, data, dimension for this data, and the threshold as parameters. And you need all these things because not all data is computed with the same precision, especially if you have some iterative procedure. And then the same call is executed in the generation of this data and placed this into a specific file. And then this data can be used as a reference when you run this code, which is differently compiled or have some patches. And that was a very convenient thing because in this case, you can make as much as many tests and just use them. We even make some simple web interface for this purpose. So you have some developers that was making some corruption to the code or some good things. It goes to a master version. Then some test machines are picking up this version, do the testing, and report this to web server so developers can see what is going on and fix these problems. And this is a really nice thing because you have cycles. So you go to work, you do some, you check the test page, and then you do some changes. So what is wrong with all this idea after 20 years of use? Well, we always have to think about these thresholds. It's not very obvious how accurate is your data. Some tests we simply have to skip in some cases because because of some for instance, if you do some sorting of a data, or it can come with a different order, then you simply can't test this. It's also quite unclear what to do if you have some, not a different number, but for instance, missing number or new data. Is it an error or not? And also this analysis was done in the runtime, so any error will simply stop your calculation. So a lot of minor things, but the main problem here is that too few quantities are tested because you usually test only publishable quantities, numbers which you can compare. And that, believe me, it's not a true thing to do. Now, in Molkas and Open Molkas, we have something like 300 tests. But first of all, there is low coverage of different branches. We are testing only 10% of all of them, and even smaller number of tested data. So how to change this? Well, a little bit of thinking. And I was thinking that, first of all, it should be a post-processing. So it should work like a pair of Calgrind and K-Cashgrind. And if you're doing development and these words means nothing to you, it's a good idea to Google and install these tools. It's very useful tools. The same thing, another question is how to make the collection of the data as automatic as possible. Because if you ask developers, please add some calls in some places, we will never do that. And another thing, then you have to gradually increase the amount of this tested data. So again, it's simple thinking, and there is one place, if we are talking about Fortran codes, where all data should be more or less defined. It's the end of subroutine. And it's very easy to identify place. And we can, of course, make these things conditionally. And you don't want to do some manual editing. You have a script, which I wrote for really something like 2 hours. And sorry for saying that it's not Python, it's a Perl. Then this script is trying to detect all parameters of a subroutine, trying to detect, if possible, all integers, because usually integers are stable. It's trying to identify strings and try to identify array sizes. So of course, if we are defined with a star, there is no way to know the size of this array. But if it's defined here, then you can use this as a parameter. So this script is simply placing this part, which is picked up from parameter list, to the end of subroutine. Simple like that. So how to test this new system? I took SCF directory in Molkas and push the button. And in 2 seconds, I was inserted more than 100, or I was edited more than 100 files. More than 500 calls were inserted. And the only thing which you might tune later is the sizes of these arrays or sizes of this data. You make compilation with this flag, and then the result. For H2 molecule, we are testing not 2 objects as it was before, just energy and dipole moments. We are testing 290 objects. For bigger cases like butadiene, it's 2060. And since the analysis is post-processing, then you can have some small GUI, it's under development yet, which will tell you where the program started to deviate from reference numbers. So I hope that this tool can be quite useful in the code development. You can catch a lot of errors, which was difficult to catch before. So final part of my talk. It's about some standards in input and outputs, and about classification of quantum chemistry outputs. Since the beginning of this century, I think it was started about 2004, there are many attempts to make some common formats in quantum chemistry. There are some successful stories. It's a CIF format in crystallography. Basis set exchange is, I think it's very good, a successful story when you try to find out a way how one program can communicate with another program. And less successful story is to make some unified language which will be understood by all quantum chemical codes. A lot of discussions in this area, they actually ends up in discussion about should it be XML, JSON, or whatever. And I just listed some successful or some promising projects, in my opinion, in this field. ChamXML, MOL SSI, Quixote project, the recent Gaussian initiative to have some common API. And also we need to think about possibility to search for our data. One small comment here. When it comes to some markup things in quantum chemistry, or sorry, in informatics, I'm trying to rush a little bit, sorry. There are completely 2 different ideas. One idea is based on XML-like language, when you have some data which is tagged, but there is a compulsory thing, you have a dictionary. You define things first, and after that you use them. But there is an alternative, which you, of course, know quite well. It's HTML. When you have similarly looking tags, but there is no dictionary. And if something is misunderstood by your browser, it simply go on and doing something. So all attempts to build some markup language for quantum chemistry, they are based on XML ideas. So everything should be defined. But what I was thinking, that we can do something completely different. And this prototype of this idea, it was my presentation in 12 years ago. So this is a picture of me picking up and sorting mushrooms, and how you do targeting or tagging in social media. Well, you do this not in an accurate way. You can find out the time when the picture was made. You know, you can recognize this photograph and see who is this person. You can see some funny labels here. Maps and so on and so on, but all this information not necessarily is a dictionary information. And even more, some of this data is wrong. So for instance, I will never show you the place where I'm picking up mushrooms. So instead of using dictionary, we can use tags. And then it's quite simple idea. We have to find out some files which looks like outputs, search for some keywords, which we know. Of course, they will be program specific. To, for instance, pick up information, 1 minute, about, for instance, geometry and so on. So this is an example how this script looks like. You first of all looking for the files. After that, you're making some simple regular expressions. And then I'm checking my computer. So I run this script and I find out that I have 11,000 log files, which looks like quantum chemistry outputs using different programs. This is how this hashed tag file looks like. And then I can write some simple query script, which will show me how many basis functions I'm using, what kind of other stuff I'm using. And for instance, I can find out that among my calculations, the biggest calculations which I did was with 113 atoms. This is maximum number of basis functions and so on. And you don't need to, well, it's indeed, I'm talking about script which was written in something like 1 hour. So just conclusion for this part, and this is almost my last slide. Well, you have to think and make some calm planning, because else if you do things in a rush, it might be wrong. I think that we shouldn't wait for some great solutions, great standards. We have to do things now, because it might be the fastest way of doing this. And another question, when I will finish debugging and polishing these codes, what should I do with them? Because I think that it's a good idea to share some ideas and some codes which are doing some nice things for our quantum chemical codes in some place. And so this is the reason why I decided to come here and present this. So thanks for Molte's developers and users, open Molte's community, and some places which make some, giving some money. And thank you so much for your listening.
Thank you. I think we have time for one quick question. Please.
So Valera, we're very much soulmates, I can tell. But when you sort of said about the standards and that, I totally agree with all your views. And I started looking into this actually about 3 or 4 years ago, and I found something that is actually doing a fantastic job. Have you looked at what they're doing with Materials Project?
Yes.
You've seen that they've got, yep, and you don't want to do something like that? Because I think it's brilliant. They've got provenance, they've got metadata, they've got sort of like standards sort of defined for the community to adhere to. They've got this graphical interface. I was going to try and find it for you, but you obviously know it, where you can pull up a calculation. It will tell you all that information that you're sort of saying that you want.
Yeah. The thing which I was telling many times on many different occasions as a representative from Malta, but whenever some standard will be available, no matter who did that, even Gaussian, I will follow. It's a nice thing to have some interfaces, because that means that I will get for free some indexing of my data. I will probably have for free possibility to make visualization and so on. So the things which I don't want to do by myself. But I was just trying to think how difficult it is to make it by myself. It's not a very big deal. But thanks for the comment. And again, how many of you know about this? We need to spread out the knowledge about the tools which we are using, codes which we are using, and some web-based things and so on and so on. That should be well, of course, I know that some, yeah, I'm looking at you, but sometimes I feel that I'm missing the possibility to have some really good communication with other developers who are doing development of different codes. Oh yeah, material clouds. Yes. But I understand what you mean. Yeah.
Okay. Well, let's thank